Hello student, today we are going to start our next topic from the class 11th, that is very first topic, that is units and dimension. See, in order to study physics, we need to have certain measurement. Then we have 7 fundamental units for measurement. What are they? 7 fundamental units. For mass, what we have, it is kilogram. For length, what we have, meter. Then for time we have second. Then we have for temperature, we have Kelvin. Then for number of substance, we have mole. Then for current, we have ampere as a unit. And then for luminous intensity, we have unit candela. These are 7 fundamental units. Then we have 2 supplementary units. What are they? Supplementary units. They are, first, see what we have. This is theta angle of the here. This is the length of the arc, and this is radius of the circle. Then the theta angle, which will be written in terms of radian. It is what? Length of the arc upon radius. Length of arc upon radius. The unit is radian. Then we have for solid angle, what do we have? For solid angle, let us suppose the area over here is A. This is the radius. This is solid angle. It will be measured in steradian. It is equivalent to area which it makes on the surface of a sphere divided by the square of the radius. These are 7 fundamental units. For mass we have kilogram, for length we have meter, time we have second, for temperature measurement we have Kelvin as standard, the number of substance in terms of it will be in mole, current will be in ampere, and luminous intensity, that is the measurement of light, it will be in candela. Then we have supplementary units. They are radian and steradian. Steradian is for solid angle. See, then we have numerous derived units. These are fundamental units, and there are other units which are derived using this fundamental unit. They are what? Derived units. For derived unit, what we have? We will study first. Study length. Unit of length. What is length? Or we will go for like distance. What is distance? Unit of dimension formula for the distance will be what? Dimensional formula. It will be L. And length is what? It is length. Distance is what? It is length of path traveled by body. Length of path traveled by body. Then we have displacement. Displacement. Again, the dimension formula will be L, and it is what? It is shortest distance between initial and final position. It is shortest distance between initial and final position of the body. Then we have speed. Speed is basically what? It is distance upon time. Dimension formula will be L by T, or it can be written as LT minus 1. Again we have velocity. It will be what? It will be equivalent to displacement upon time. Displacement is again L, this is T, this is coming out to be what? LT minus 1. Then we have, this is first, second, third, fourth, then we have acceleration. See, acceleration is what? Velocity upon time. Velocity is what? LT minus 1 upon T. It is coming out to be what? LT minus 2. Then we have force. Force is what? Mass into acceleration. Mass is what? M. Acceleration is LT minus 2. Then we have work. Work is what? Force into displacement. Force is what? Mass into acceleration into displacement is m less T to minus 2. Then for kinetic energy will be equivalent to potential energy. It will be again ml square T to power minus 2. Then we go for power. Power is basically what? It is work on time. Work is what? ml square T to power minus 2. Then we have time. It is coming out to be what? ml square T to power minus 3. Then we have momentum. Momentum will be equal to what? Mass into velocity. Mass, velocity is what? LT minus 1. Then we have impulse. Impulse is what? Force of rotating time or change in momentum. So again it will be mlt minus 1. Then we have stress. The stress is basically force upon area. It is basically dimension is equivalent to that of pressure. Then what we have? Force is mass into acceleration divided by area. This is coming out to be ml minus 1 T to power minus 2. Then we have dimension for the strain. The strain is what? It is basically change in configuration upon original configuration. Delta L upon change length upon length. So it is coming out to be dimensionless. M0, L0, T0. Then we have modulus of elasticity. It is equivalent to what? The stress upon the strain. The stress is what? This L minus 1 T to power minus 2. This elasticity will be equivalent to that of the Young's modulus. It will be equivalent to the bulk modulus. It will be equivalent to the modulus of rigidity also. Then we come to our next topic. We have next topic, that is we go for dimension of capital G. Force is what? Because in Newton's law of gravitation is coming out to be what? Force equal to G ml into upon r square. So what we have? G as F into r square upon m square. Force is what? Mass into acceleration into L square upon m square. This is coming out to be m minus 1 L cube T to power minus 2. This is what? Capital G. That is universal gravitational constant. It has value how much? It has value of 6.67 into 10 to the power minus 11, and dimension is m inverse L cube t to the power minus 2. Then we go for the coefficient of viscosity, eta. What is that? Coefficient of viscosity. See, we have force. Basically, it is acting on a body when they are flowing. It is friction of the fluid, and force is what? Eta into A upon V upon X. Eta will be equivalent to F into X upon A upon V. We will get the dimension as M L inverse T inverse. Then we will go for the dimension of the Planck constant. Planck constant. See, over here E is what? E is equal to h into nu. H is Planck constant. It is coming out to be energy upon frequency. Energy is ml square t to the power minus 2 upon t inverse. It is coming out to be ml square t to the power minus 1. So these are the sum of the dimensions. Dimensional formula of certain physical quantities. Now we go for how one unit can be converted into another. Suppose we have 1 joule and we have 1 erg. Both are unit of work. See, what is 1 joule? Work is basically force into displacement. 1 joule of work is said to be done when 1 meter of force displaces the body by 1 meter. But in the case of this is in SI unit and it is in CGS unit. See what we have? Work is basically force into displacement. Over here it is 1 dyne and the force is basically equivalent to work is 1 dyne, work is 1 erg basically. Force is 1 dyne and this displacement is 1 centimeter. So how these two quantities are related? Because both are dimension of work. So we have the formula N2 is equal to N1, M1 upon M2 to the power A, L1 upon L2 to the power B, and T1 upon T to the power C. We know that dimension of work is what? M L square T to the power minus 2. So what we have? This is 1 joule. This is in SI unit. This is 100 gram. This is 1 gram. Power is 1. This is 100 centimeter. This is 1 centimeter. Power is 2. This is 1 second. Power is 1 second. This is minus 2. So what we are getting over here, it is 10 to the power 3 over here. This is 10 to the power 4 over here. So overall we are getting 10 to the power 7. Means 1 joule is equal to 10 to the power 7 erg. Then we go for the force. In case of force, what we have, we'll see that in case of force, standard SI unit is Newton and in CGS it is dyne. So see, force is what? Force is basically mass into acceleration. Mass force is what? 1 Newton when it is acting on a body of 1 kilogram and produces an acceleration of 1 meter per second square. But in the case of dyne, 1 dyne is that force which is then acting on a body of 1 gram and produces an acceleration of 1 centimeter per second square. Now we want to correlate these quantities. So again, this is in SI unit, this is CGS unit. So what we do? Formula is N2 is equal to N1. This is M1 upon M2. This is to power A. This is L1 upon L2 to the power B. This is T1 upon T to the power C. Suppose this is 1 Newton, mass is 1 kilogram, and force has dimension force into mass into acceleration. This is dimension formula for force. This is 1 kilogram divided by 1 gram. This is power 1 meter. This is 1 centimeter divided by power 1. This is 1 second, power minus 2. So what we are getting from here, you will get 10 to the power 3, from here you will get 10 to the power 2, this is coming out to be 10 to the power 5. So what we have, 1 Newton is equivalent to 10 to the power 5 time. Now we from this, in this chapter we also learn to derive the new formulas. See, suppose we say that using principle of homogeneity, using principle of homogeneity, we will be able to derive any formulas. Suppose we say that time period of simple pendulum depends on the length power A and acceleration to the power gravity is V. It depends on the length and acceleration to the gravity. So what are the power of A and B? We will be able to get through using principle of homogeneity. See what it says? It says that over here it is M0, L0, and this is T to the power 1. Over here length is L, power is A, and for gravity what we have? Meter per second square. So power is B. Using principle of homogeneity, see, this is L to the power A, this is L to the power B, which can be written as A, L A plus B, and this is coming out to be what? T minus 2B. This is what? M0, L0, T to the power 1. See what we have? Using principle of homogeneity, what will be A plus B will be equivalent to 0. And minus 2B will be equivalent to what? 1. So B is coming out to be minus 1 by 2. Placing the value over here, A will be equivalent to 1 by 2. So this is, we will say that L to the power 1 by 2 and G to the power minus 1 by 2, which can be written as K L by G. So using principle of homogeneity, we will be able to find any formulas with the help of these formulas using this principle. If we want to know the formula for the T and there are various factors on which it depends, we will utilize this formula and derive the result. And next thing, and there are a lot of things to be done in this topic, but we'll do in the next class. That's all for today. Thank you.